Hello, I'd like to welcome you to our digital classroom. I'm Jerry Winslet along with Jason Leonard.
Hey, how you doing?
And today what we're going to be talking about is the standard atmospheric gas water heater. It's actually changed a little bit from the previous design. The new Honeywell gas valve is on there. And what we want to do first is we're going to talk a little bit about what's changed from the older model to the new model. I'm going to talk a little bit about some installation tips that you might want to keep in mind, how the water heater works. And then we're going to get into troubleshooting, and we're really going to kind of walk through a scenario that you might experience from time to time if you do any kind of work on these water heaters. But let's go ahead and get started. We got a lot to cover. So the first thing we want to talk about is, you know, it's a standard atmospheric gas water heater. We don't plug it in for electricity or anything like that. Now, you know, this has been around for a long time, this kind of technology. But there has been some updates, and in this recent update, we changed the gas valve. Let's talk about the gas valves and kind of what's changed and what's different about this unit.
They have changed a little bit. You guys are extremely familiar with the old mechanical style gas valve. We've run these for years and years and years with really very little design change whatsoever. They were pretty bulletproof.
Right.
We used them for a long time. The only problem is they don't give you a lot of information. Everything on it's analog. It's all mechanical. So it requires a lot of troubleshooting and diagnostic testing and things like that if we have a problem. Now the new Honeywell valve that you're talking about, it's been around for a little while. We've had it out for a little while, but there's so many of these mechanical style valves out there. We think it's worthwhile to talk about the differences and what's changed. You probably see this on a regular basis. You're probably starting to see this more and more frequently, but this is pretty much what the industry has gone to as a whole, is the electronic style gas valve. And if you'll notice, one of the first things you'll see is right there on the front, we see a lot of different error codes. We see some status light codes. Now this valve can actually talk to us a little bit. It can interact with us, tell us a little bit of information, and do some of those diagnostic tests for us.
Right.
That's really the main benefit from this style of a valve. Some of the other changes you're going to see is kind of on the valve itself. If we look at the old style, we've got our pilot, and our on and off knob is right here on the top. Some of these actually had two buttons on top.
Right.
You had a pilot, plunger, and you had an on and off. This one just has the single, the pilot plunger is built into it. So you just purge your pilot from there, and your big temperature and control knob where you set your temperature. This is all incorporated into one. If we look at the front of the Honeywell valve, this is our temperature control. If we push in on it, that is also where we purge our pilot valve as well. So that's kind of incorporated into one button. The older style run a piezo igniter that was attached to the outside of the valve. You had just a push button piezo igniter. Here, that's actually incorporated into the face of the valve. We see our piezo igniter right there. So if we push on that, this is how we would ignite the heater.
Okay.
Now, another big change, if you look at the back of the valves themselves, we see that this looks completely different now.
Right.
The older style, this is what we refer to as the rod and tube style temperature probe. And if you think about it in terms of a cell phone, we can all kind of relate to that. This would be our analog technology.
Okay.
The rod and tube style. Basically, you're relying on the expansion and contraction of metal in order to tell you what the temperature is. There's basically a steel rod inside this copper temperature probe, and it expands and contracts, and that's how we tell temperature. If we look at the other valve, we see that the temperature probe looks totally different. This is what we refer to as a dry well thermistor. There's a thermistor inside this temperature probe here. We refer to it as dry well because the thermistor doesn't actually come in contact with the water. It sits inside this housing. This is digital technology.
So now we're at digital. We had analog. Now we're at digital.
Exactly. By doing that, now we can more accurately determine what the temperature is. With a rod and tube style temperature probe, you could have a 15-degree variance in tank temperature based on the rod and tube style. It was also a little bit slower to react. As it started to see some temperature differential, it took it a little bit to tell you when that changed. Once we go over to digital technology and go with the thermistor, we can actually determine temperature down to 1/10 of a degree.
Right.
These are about 2 degrees because, again, they're dry well, not wet well. But we can get about a 2-degree differential.
So
on these.
we're more accurate with this?
Much more accurate.
Now, you're talking about, you know, we don't plug these in, but yet we're running lights. Now, we didn't run lights on the older style, you know, and we're all familiar with really how they work, but let's kind of talk about that. How are we able to run lights on this water heater as opposed to not running on the other?
Yeah, and as we stated, that's kind of the big benefit here. We see the status lights on the front of the valve here, and we also see the little light. We got the little flashing light. We just tell how many flashes corresponds with the sticker on the top, and that'll tell us what kind of status code that we're in.
Okay.
Now, in order to do that, we're going to have more power. As you stated, this water heater doesn't plug in.
Right.
For years and years, we have generated power for an atmospheric water heater through what was called a thermocouple. You guys are totally familiar with these. They've been around forever. Your standard 24-inch thermocouple you can pick up at any hardware store. Same exact thing. Basically, this sits inside the pilot flame. That flame gets transferred into voltage that gets produced at the other end of the thermocouple. Now, that is what ran the old mechanical style valve. They run about 10 millivolts. Anywhere between 10 to 30 is about what you could expect to get out of one of these. But that was enough to run the power head inside the old mechanical valve. Now, the new electronic valve uses an electronic version of the old school thermocouple. We refer to these as a thermal pile. Same principle. They work identically. There's really no difference in the operation. The end of the thermopile is going to sit inside the pilot flame, and again, voltage gets produced on the other end here. So our voltage will get produced on these little spade connectors, while the other end sitting in the pilot flame. Now, again, we're going to need a little bit more power. The thermopile is going to produce anywhere between 350 upwards of around 900. It's going to produce a lot
more than a thermocouple.
Yeah, a lot more. But basically, all a thermopile is you take a thermocouple, we can get a little bit of voltage out of that. Well, if I take a lot of thermocouples, I can get even more. That's basically what a thermopile is. It's a pile of thermocouples.
Pile of thermocouples.
Yeah, we take several of these and bound them up into one housing, and that becomes your thermal pile. And these have been around for years. They use them on a lot of different things.
Okay, so that's how we're generating power. I do want to mention that anytime during this this broadcast, you can ask questions. You can use the chat feature, which is on the right-hand side of your screen. I'll keep reminding you every so often during the show. Any questions at all, just go ahead and ask those questions, and we'll get to them. After the show, what we'll do is we'll do a a question and answer session and answer as many questions as we can. But just feel free to ask the questions and just put them in that chat feature. So really, that's all the changes really on this water heater, because all the rest of the stuff is pretty much the same. You know, we still have a flame arrestor and a door switch and things like that.
Yeah, as far as the combustion chamber, the flame arrestors you're pointing out, the door switch and things like that, we've used those for several years now. There's really no design change to the actual skirt and base and flame arrestor and all that. The main change is in the valve, and again, how we're powering that valve with a thermal pile.
Yes, so more power, more bells and whistles we can use. So,
exactly right.
But one thing that I want to make clear is that the only time that you can have a status light is if you have a pilot. As long as you're heating this thermal pile up, you're able to have a status light. If you don't have a pilot, you're not going to have any lights at all.
That's right. All of those status codes are dependent on the voltage that gets produced by that thermal pile.
And a pile of thermocouples, that's good. We're going to use that.
That's
that sounds good. All right, what we're going to do right now is we're going to go over to a water heater. We're going to talk about how the water heater works. You know, can I kind of briefly go through that, and then let's talk about some installation tips and troubleshooting,
Sure.
okay? All right, so let's go on over here. All right. We are here. So this is a standard atmospheric gas water heater, atmospherically vented. And what I'm assuming is heat rises, so we're using natural rise in this water heater. You know, we still need the 12.5 cubic feet of air per 1,000 BTU, so we're taking in air at the bottom, and then we're also having air at the top with the draft hood. Let's talk. Has anything else changed on this? I mean, let's talk about a standard atmospheric water heater and
well,
really.
Again, And what you pointed out, the basic principle behind this, again, is natural heat rise. The draft is being induced in an atmospherically vented water heater by the fact that hot air rises above cold air, right? As that hot air rises, it's going to draw in cooler air into the combustion chamber. That happens down here at the bottom of the heater. So all that heat that's coming off the burner is rising up through the heater. We want that because that's how we heat water, right? But in order for that process to continue, we have to pull in cooler air at the bottom and exhaust that hotter air at the top of the unit.
Okay.
Just like your car, right? You're going to have to bring in an air into the front of the motor. You have combustion, and then you have to exhaust that out the tailpipe. Same type of deal. This is our intake down here. This is our exhaust pipe up here.
Okay.
If we block this up, if we stop this motion at any point in time, then we're going to start to overheat the combustion chamber. We're going to stop the draft. We're going to have to start having some problems that we're going to talk about here in just a little bit.
Now, how efficient is something like this? Like thermal, how much heat are we actually putting into the water?
That's a good question. They have got more efficient over the years. As far as thermal efficiency, and what we mean by thermal efficiency, how much heat that we're generating actually goes into the water. We know that we get some loss through the venting system, correct? But how much loss is there? Most standard atmospherically vented water heaters today are around 80% thermal efficient. What that means is 80 cents of every dollar that you spend on fuel actually goes into the water. So that's what we mean by thermal efficiency.
Okay, all right. So we're about 80%, and you know, I mean, we make water heaters that are very highly efficient. We're up to 98% thermal efficient. That means we're putting it all in there. You know, with this water heater, when we install the water heater, is there anything that we really need to be thinking about that you know, I'm assuming most of these water heaters is just a replace and place job?
Yeah, 80% is going to be a replacement market. It's going right into a situation where the old heater came out. The old heater leaked after, you know, 15, 20 years, so they have to replace the water heater, and that's why they're putting in this one now. The main thing you have to worry about, again, what we talked about earlier, that natural draft. Hot air rises above cold air. And hot air in equals air out. It has to. They have to balance. So the biggest thing that you want to look at is, first, do I have adequate combustion air? Is the water heater in a location to where I can efficiently feed it with makeup air? Or is it in a room that it may possibly being drawn negative? If I'm creating negative air pressure inside that room, it's going to be very difficult for this heater to draw in combustion air.
So that means that a room we're pulling all the air out of the room.
Absolutely, absolutely. If it's in a room with a clothes dryer or something like that, there's some things that we need to worry about. So installation location is a big deal, and really because of that makeup air. We have to have that makeup air. The second thing you want to look at is look at the venting system. Again, 80% of these are going to go into a replacement market. They're going to hook up to the B vent that was already there. You do want to take this in consideration. I'm not saying that you're always going to have to change the venting out. I'm just saying that you need to look at it and make sure that it's going to work with a new, more energy efficient water heater. If the heater that you're replacing is 10 or 15 years old, it is probably not as efficient as the one you're putting in today.
So if it's not as efficient, that means our flue temperatures are going to be hotter.
Our flue temperatures are cooler the more efficient
No, if it's not as efficient.
That's correct. That old heater, it may have had a draft temp, you know, 300 degrees, and because now we have more energy efficient products, the draft temperatures are a lot lower. It may be 250, it may be 200. So we have a lot less heat to work with. Now that's a good thing. Again, we want more of our money actually going to the purpose that we're trying to get, to heat that water. But it is a give and take. The more we put into the water, the less goes into the venting system. So take a look at it. If there's a lot of 90s or anything like that, you might want to try to get rid of those 90s and put in 45s instead. If there's any way to shorten the vent run or something like that. Again, I'm not saying that this always has to be done. All I'm saying is on a new install, we have to look at the total picture from intake to exhaust. And is it going to work with the heater that we're putting in today? Again, air in equals air out. You have to look at it.
All right, that's a good tip. Something we really need to keep in mind is you know, location of where the water heater is going to be installed. You know, now this kind of brings up really what we wanted to talk about is really troubleshooting on this water heater. And really, when we're talking about troubleshooting, we're talking about really one call. It may sound, you know, kind of different, but it's all the same call. It's no hot water. You know, they don't call you and say, hey, my water heater's working great. No, they call because they don't have any hot water.
Yeah, they don't call in and say, hey, my thermocouple's not producing as much voltage as it used to. They never say that.
No, they never
That's
do.
not the call that you get. The call you get is, I don't have any hot water.
Yeah.
Now, that could be because of a few different reasons, but the initial engagement of that service call is going to be no hot water. So what we want to talk about, being that that's the number one call, what do we do when there's a call that comes in, a no hot water call, we arrive on site, what do we want to do now?
Yeah, I mean, if I'm a service guy, I get a call and it's no hot water, what is the first thing that I am supposed to do?
Well, the first thing you want to do is determine, what do we mean by no hot water, right? Are we talking about one faucet, or are we talking about the entire house? Because that could be drastically different. We could have a shower valve that went bad, and that's producing no hot water in the shower. So the first thing we want to do is make sure we actually have no hot water everywhere. Check all the faucets, make sure there's no hot water coming out of any of them. You can also come to the heater. Check the TMP valve. Put your hand around the TMP valve. If you feel heat here, then the heater itself is making water. There could be a number of reasons why that's not getting out to the faucet. But if you're cold here and cold at every faucet, then this is actually a no hot water situation.
All right, so we've determined that we have no hot water. And so what is my first steps? Let's go ahead and start with the troubleshooting.
Well, let's get down here on the heater itself. The first thing that we want to do is, once we have no hot water, then we're assuming that we have no burner, we have no pilot.
Right.
The heater is off, right? That's the whole reason why we don't have any hot water, because the heater's not running. So the first thing we want to do is go ahead and light the heater. We're going to do that following the lighting instructions that are on the front of the heater itself.
Okay, so I'm going to come up to it, I'm going to look, and I won't have a status light if the water heater's not working, right?
Yeah, if nothing's working, that means the status light's not going to be flashing, nothing's going to be happening. If that pilot is out, again, what we talked about at the desk, if that pilot is out, then you're not going to get any status light whatsoever, because that status light is dependent upon the voltage that's being produced by that thermopile. So if that pilot is not on, we're not going to get any flash whatsoever. So you're basically going to see a dead valve when you come to the heater. So the first thing we need to do is go ahead and
go ahead and relight the pilot. I'm going to hold my pilot knob down, follow all the lighting instructions, and it's basically you're holding the pilot down, and I'm going to be clicking my igniter button once a second until I see a blinking light.
Yeah, and again, what we're going to do, when we push down on this knob, you're basically purging the pilot valve at that point. And then we're just going to hit our PZO igniter, and we're just going to hit that, you know, every couple of seconds, and just keep doing that for about 90 seconds.
Yeah, because it's all we're doing is we're looking for this light to start blinking.
Yeah.
Gone are the days where, you know, with this water heater, well, it's not in every sense, but it's a little bit easier to light this, because all you're going to do is hold this pilot knob down, click the igniter until you see a blinking light, instead of looking through the sight glass.
And it may not take 90 seconds. The reason we say 90 seconds is because you're waiting for the voltage on that thermopile to heat up enough to where we can actually produce voltage to run the valve.
Right.
Now, depending on the age of the unit and the age of the thermopile, that may happen pretty quickly. So it may not take 90 seconds. Once you start to see the status light start to flash, then you can let go and you're fine at that point.
And then turn it up.
But it could take up to 90 seconds, especially if the thermopile is a little bit old.
All right, so I'm out there, I'm holding this down, I've been pressing my igniter button, and I don't have a status light, and I've been doing it for a few minutes now. What's my next step?
The first thing you want to do is look inside the sight glass itself. Now, you guys know how this is. Sometimes it's a little bit difficult, especially if the water heater is in a closet.
Right.
And they got winter coats and Christmas trees and everything else piled inside.
That could be the reason why it's not breathing right.
Very well could. Sometimes you have to kind of stand on your head with a flashlight in your mouth and look inside that light, inside that glass. So sometimes it is a little bit difficult, especially depending on where the heater's at. But the first thing I want to do is check this sight glass and see if I'm ever getting ignition on that pilot at all. I'm going to hold this down. I'm going to look inside that pilot glass and just click it off.
Okay.
Again, I'm looking for a clear blue light.
Okay.
We used to see a pretty big honking flame inside the bottom of the heater as a pilot light. Because water heaters are more energy efficient, that pilot flame's a lot smaller than it used to be. Again, that thing is burning 24 hours a day, 7 days a week.
And really,
so by reducing that, we can save some fuel costs.
And you're really going to have to kind of look up and to the left. That's really where you're going to see it. But you're going to hold the pilot knob down and click this igniter button. You should see the spark. Because you got to have those three things for combustion. You got to have a spark, air, and a fuel. And if I'm clicking this, I've got my spark. I can see the spark. I have air because we're breathing. We've got air in there, enough to light the pilot. But I'm not lighting the pilot. I'm clicking this, and I don't see a flame. Where am I going from there?
Well, the first thing we're going to do, as you pointed out, again, are we getting spark?
Yeah.
If we're never getting that flame, make sure you're getting spark. This can be difficult to see inside the heater, again, like what we were talking about earlier, depending on where this heater's at. That little bitty tiny spark in there may be difficult to see. You can unplug this, just unplug this Molex connector from the igniter itself, hold it over to the pilot tube, and click away, and you can see it jump to the pilot tube at then. That way you know that the PZO igniter is actually working. If you are getting spark, if you can see it inside the chamber, and we never get ignition at all in that pilot flame, then the issue is going to be on the gas side.
Okay.
You want to go down the gas road at that point. Now, it could be that the gas valve is shut off, somewhere in line. Could be at the meter shut off.
Right.
If it's a new install, you could just have some air in the lines.
Right.
On a new install, especially when you're breaking these gas lines, you may get some air in that gas tubing somewhere. So you may have to purge that down. Now, if you're trying to purge that through this small little pilot valve, it's going to take some time. Again, 300 BTUs an hour is all this thing moves.
Okay.
So if you're trying to purge it from here, you're going to have to hold it for quite some time.
All right.
So you want to purge that through the line somewhere else, either here or a dirt valve or wherever you want to purge it at. Just get all the air out of the lines, and then come back and start this lighting procedure again.
So if I'm holding it down, I look through there, I have a spark, and I don't have a blue flame, and I've been doing this for a while, then it's something on the gas side. We're going to be looking down the gas road, shut-off valve. You didn't pay your bill. I mean, if you didn't do that, that'd be a bad thing.
That's right.
But it's something on the gas side.
Yeah, as you pointed out, you have to have three things for combustion. We have to have fuel, we have to have spark, our ignition source, and we have to have oxygen. And again, oxygen's there, we assume. We can physically see the spark. The only thing left is the fuel. So I'm going to go down the fuel road.
Okay. All right. Now, let's say I'm trying to light the pilot, still have no status light. I look through the sight glass, and I do see a blue flame. I've been pressing this igniter button. I stop pressing it, holding down the pilot. I see the blue flame, but I never get a status light, and when I release the knob, it goes out. Yeah. What's my issue there?
Now, if we have a flame, then we have to assume that we have enough heat there to create the energy. Something is impeding that energy from getting back to the valve. There's a couple of different reasons for that. Maybe something is just stopping the voltage, or maybe the thermopile itself is not producing it, one of the two things. So the first thing we want to do, again, we have a pilot flame goes out as soon as you let go of the pilot knob, and we're never getting an indicator light. First thing you want to do is check all your connections. Check every connection, make sure everything is plugged in good and tight. If one of these wires are loose, then it's going to break the continuity on that circuit, and we're not going to get that voltage back to the valve.
All right, so something electrical on the thermopile side.
Yeah, exactly. Again, if we don't have a flame, it's gas. If we do have a flame and it's going out, it's electrical. Okay. So check your electrical connections. Once you determine that all of your electrical connections are fine, and we're not losing any voltage because of a wire that's disconnected, the next thing you want to do is go right here to our door switch. Okay. And see if this door switch is tripped. Now, you can do this a couple of different ways. One, we can just push in on the little reset button on the back of the thermal switch itself. If it is possibly tripped, you may feel a click when you push it in. It's pretty slight, so you may or may not feel it. So push that in. If you feel that click, then it probably reset. Now, if you can't feel it, one thing you can do is pull these wires off. If you'll just pull these flag connectors.
Now that's just a switch. That's just a switch that's a normally closed switch that opens up on a rise in temperature.
That's exactly right.
You know, it's got a, you know, electricity can pass through it. So that switch is connected, and whenever the temperature gets too high in the combustion chamber, it opens up and breaks that connection.
That's exactly what it does, just like you cut the wire.
Okay.
Basically, when this thing is closed, it's a closed circuit, and electricity can travel through it. It activates on heat. It's checking the temperature inside the combustion chamber. And if that gets too high, basically that switch opens up, breaks that continuity, and now that voltage could not travel through it.
Okay.
So the voltage that gets produced by the thermal pile will really stop right here on one side of the switch.
Okay.
Now we can see if that's happening by using a multimeter. We can take our multimeter and we're going to check continuity is what we're looking for. So we're going to set it to the continuity setting. That usually looks kind of like the Wi-Fi symbol on an airplane or a speaker symbol, a sound symbol. Another way you can tell that you have it on that setting is if we put our two temperature probes, our leads together, notice we get a beep. That's the continuity beep to tell us that continuity is present. We have a closed circuit, and that beep is telling us that. So once we have it set on that setting, all we have to do is take these two probes, and we're just going to set those on the actual sensor itself, where those two flag connectors came from. Now we can see that this one is beeping. So the switch is closed. We don't have to worry about the switch. The switch hasn't tripped. Now, if we don't get the beep, say we push this on there, notice nothing happened. If we don't have the beep, then now we know then that switch tripped.
Okay.
Now, there's a couple of different reasons that could cause it to trip. We know it's because of heat, because that's the only thing it's going to activate upon. So either we're not getting enough combustion air into the bottom of the heater, or we're not able to exhaust the gases properly. You want to check here first. Check your intake air.
Okay.
You want to go in, clean your flame arrestor. Is going to be the #1 thing you want to do.
Yeah, because that's really what happens most of the time is a dirty flame arrestor on a trip door switch. And really, you know, clean the flame arrestor. We have videos on that, on how to clean the flame arrestor. Knowledge articles. If you ever call in here to the 800 the call center, they can walk you through that process. Also, we have cleaning kits that are available. You can call the call center. We'll get you those kits. Those are free, free kits. But really, what comes with it is this is your friend. This is a long handle soft bristle brush. What you're going to do, obviously the water heater's been off because we have no hot water, so it's cooled down. But you've got a filter here at the bottom where we have our air intake. You're going to take that filter off. It kind of slides out of this little channel. It's in a channel, and let me get that out. And here's your filter, and that filter's there to catch any lint, dust, and debris. But let's say, for instance, somebody left it off or something like that. That can happen from time to time. But in any case, the flame arrestor is dirty. So how you're going to clean that is you're going to put the long-handled soft bristle brush in this air chamber, and you're going to clean the bottom of the flame arrestor. While you're doing that, you're actually, this head of this brush is actually as wide as this air chamber is tall. So you're getting the bottom and the top at the same time. So you're going to clean this flame arrestor. You're going to pull it out, take a vacuum off the lint and debris, and you're going to keep repeating that process until you pull out this brush and it's pretty much clean. And that's how you'll know that that flame arrestor is clean enough. Now, there may be some still debris and stuff on the flame arrestor, but it's probably not going to cause it to trip again. But that's really cleaning that's how you clean this, the flame arrestor on these units. There's also a vacuum attachment that you can use, but really this works very well because some units are in drain pans. You can bend this to get into that drain pan and get this cleaned out. But that's really what the cause of a tripped tripped door switch. If you experience that, then you automatically need to clean that flame arrestor.
Yeah. That's exactly right. And again, we talked about where these water heaters are located. If they're in a laundry room next to a clothes dryer, you're probably going to have to do this periodically to avoid these type of issues. That's probably exactly what's going on. We're pulling all that dust and debris, just chokes the heater out. Now,
it could be the filter as well. You need to clean that filter
absolutely.
off. Run it through some water, let it dry out. Just wash that
make
off.
sure it's there.
Vacuum it off.
Make sure this filter is there. If you're not the guy that installed this heater, whoever did may have removed this, so we may have to get him another one of these so that we can avoid those problems.
And the kits come with wraparound filters as well, so they'll become replacement filters. So we'll get you covered if you need those kits.
Yeah. And as we talked about earlier, this is only one side of the coin, right? This is our intake side. The other thing we have to worry about is our exhaust side. So once we determine that we get adequate combustion air into the heater by cleaning the flame arrestor and all that kind of stuff, the next thing we want to do is go up top and maybe do a spillage test, a draft test on the heater. And we do that by using anything that will produce smoke. We can light a match, hold that around the draft hood.
Yeah, let's go ahead and talk about how we do that.
Yeah, what we're looking at is right here at the draft hood. What we're going to do, again, is take anything that will produce smoke, a match or something like that, and we're going to hold that right outside the draft hood, about an inch away.
So we're gonna light the water heater now that we've closed the door. The door switch is closed now. So we're gonna go ahead and light the water heater. Is there anything we need to let it run at least for 5 minutes?
About
right?
5 minutes. A proper draft test takes about 5 minutes of heat going through the system to produce that good positive draft.
Another thing too is you need to close all the windows in the room or in the house, just to make sure that we have it in a worst case scenario.
Anything like vent fans or anything like that that may be producing negative air pressure. So go ahead and fire that stuff up as well. It's a good point. Close all the windows and doors and fire up any devices that move air. What we're looking at is a worst case scenario.
Okay.
And then go ahead and do your draft test. And again, what we're going to do is just take that flame, put it right around that opening. We should see that smoke pulled into the draft hood and immediately pulled up. You should be able to watch that smoke go inside the draft hood and go up. Down is bad. Floating around the draft hood is bad as well. So after about 5 minutes of operation, we should see that smoke go into the draft hood and immediately up. If you're not, then you know you got something wrong with the air. Either in the venting system or in the combustion makeup air in the room, something's causing that draft to stop, and that's why your door switch is tripping. So again, check that as well.
All right. So we're going to go back down here. So okay, that's if the door switch tripped. Now, so I'm going to try to light this pilot, and I looked through the sight glass. I didn't see the flame, so I checked my gas. Now I'm looking through the sight glass. I'm trying to light the pilot, and I did see the flame. Did see the flame, but I never see a status light. When I let go of the knob, the pilot goes out. We've checked our door switch. Our door switch is good. What else can it be?
Now, if our door switch is not tripped, again, the pilot's going out as soon as you let go of the pilot knob. If the door switch has not tripped, the next thing you want to do is see how much voltage that thermopile is producing.
So we're looking at our thermopile.
Yeah, we talked about it needs at least 350 millivolts to operate the valve.
Right.
So let's see if this thing is actually producing that voltage. So what we're going to do, we're going to take our meter and we're going to set it to DC millivolts. The thermopile produces DC voltage.
Okay.
And in a millivolt range. So we're going to set it to DC millivolts. And all we have to do is we're going to have to light the heater. Again, you're going to have to hold down on that purge knob. We're going to have to push this off until we get the pilot lit. The pilot has to be lit in order to see that voltage.
Okay.
So you may need a buddy to hold down on the knob. Lucky I happen to have a buddy. If you don't have a buddy, I'll send mine out here to you. But you're just going to hold down on that pilot knob, and then we're going to take our two probes and we're going to push them into the back of the spade connector.
So we've got a door on the back side of this connector. This is the easiest way. This is the way we want you to test this, because this is testing it connected to the gas valve. You're going to see probably a lower range on when it's connected to the gas valve you will.
Didn't. Right now you're getting a full load.
Yes.
You've got the highest resistance because everything is plugged in. So you're picking up the resistance for everything here. So again, we're looking at the worst case scenario.
That's what we want to see, yes.
Once we get the pilot lit, and again, this is a lot better than it used to be. If you have a clamp or something like that, you can actually clamp it on the side of the valve and hold that down for you. That way you can hold these yourself, or you can hold them with one hand the way I am and hold the pilot knob with the other hand, and that way works as well. A lot easier than the old style.
Yep.
But again, we're just going to look at our meter and see how much we're producing. we should be producing at least 350 millivolts. Now, with a good thermopile, you're probably going to get a lot more than that.
Yes.
You're probably going to get upwards of 600, 700, maybe 900.
Okay.
But if you're not getting 350, then you need to go ahead and replace the thermopile.
So if I like the pilot and I'm looking for at least 350 millivolts, I check all my connections and make sure they're good. Everything is good, clean and tight, and I'm not getting 350 millivolts, I'm going to replace the thermopile.
That's right.
All right, so you replace the thermopile, that's the 350 millivolts is their magic number. That's what you really want to look for. If you're getting 350, if you're not getting 350 millivolts here, and you've got a pilot and you're holding it down and all of your connections are good, replace the thermopile. Now, what if I'm not getting 300, what if I am getting 350
If you're
millivolts?
getting 350 millivolts out of this thermopile, but you're never getting the status light to flash, then it's your valve.
Okay.
Something on the valve has failed. That's extremely rare. You do not see that very often, but that would mean something is wrong with the board itself. Something is impeding that voltage from getting back. If all our connections are good, our door switch is closed, the thermopile is producing 350 millivolts, but this light never flashes and it won't stay lit, then it's the valve. You need to go in and replace the valve at that point. But again, that's really, really rare.
All right, so let's talk about this now. We're talking about no hot water. So if you're going out to a house, the first thing you're going to want to do is make sure that they have no hot water at the entire house, not just at one faucet. So we're going to verify that. The next thing we're going to do is we're going to go to the water heater, look and see if we have a status light. If we don't have a status light, we're going to light the water heater. When we light the water heater, the pilot's either going to light or it's not. You're either going to get a status light or you're not going to get one. So we're going to look through the sight glass. If we've been trying to do this for over 90 seconds, a couple minutes, if we're looking through there and we look through that sight glass and we're trying to light the pilot, we have a spark, but we do not have a pilot, we're going to take the gas road. So we're going to go down the gas road. We're going to look at, make sure that we don't have any shut-off valves closed upstream. We paid our bill. We did the right things. We're getting gas to it. That's if you don't get a pilot. If you do get a pilot, then we're going to start looking at the electric road. That means that we're holding this down. We have a pilot through there, but we're never getting a status light. And when we release it, it goes out. We're going to start looking at the electrical side. And that means that the door switch could be tripped, and then we're going to test our thermopile for the proper voltage, and it's either going to be the thermopile or the gas valve in certain scenarios. But really, that's troubleshooting this water heater in a nutshell.
That is it. It's really, really simple. Again, the great thing with the valve that we have today, it does have the capability of running status codes and things like that. If you're getting a status code, just go ahead and do whatever the valve tells you to do. If it says it's an internal failure, then go ahead and replace that. If it says that your thermopile voltage is low, then go ahead and do that. Just follow the instructions.
It comes with different status lights, but really we're only concerned with a couple of them. I mean, a 0 is obviously nothing. A 1 flash is a normal operation. And then occasionally you might see a 2 flash error code, which means it's a low thermopile voltage. But the rest of them, 4, 5, 7, 8, it's really just changing out that gas valve.
If you're getting a status code, just do whatever it tells you to do. If you're not getting a status code, light the pilot. If it won't light, it's gas. If it does light but goes out, it's electrical. Check your door switch. If it's tripped, clean your flame arrestor and check your venting. If it's not tripped, check your thermopile. If it's not producing 350 millivolts, go ahead and change it. That's it. Bada bing.
Yep. All right, what we're going to do now is, again, if you had questions or have questions about this show, just go ahead and type them in the chat window. What we're going to do next is we're going to go back over to the desk and we're going to answer any questions that you might have. We'll see you over here. All right, we're back now. We've got a couple questions came in. The first one is, we want to talk about expansion tanks, and I think the question was, can we explain the importance of an expansion tank?
Yeah, expansion tanks are extremely important. Because most homes now are on what we refer to as a closed water system, meaning there's some type of backflow prevention device on the water meter itself, the meter out in the yard. As we heat water, water expands. So we need to give somewhere for that expansion to go. If not, the water heater is going to try to absorb all this additional expansion. That means every time you go through a heating cycle, that water heater is going to expand and contract. Well, you know what happens to a piece of metal. When you bend it,
Yeah.
you bend it, you bend it.
It's going to end up breaking.
Yeah, metal fatigue. You eventually get metal fatigue, and the heater's going to cause a leak. So thermal expansion tanks are really critical to the duration of the water heater, the lifespan of the water heater. Without it, that water heater is not going to last as long as it will otherwise.
And the thing about a thermal expansion tank as well is a properly installed thermal expansion tank.
Yeah.
You know, when you're installing these expansion tanks, you want to put it between the water heater and any type of backflow check valve, safety valve.
Yeah, if you look at the I&O manual that comes with those, they're going to tell you 18 inches from the water heater. It really doesn't matter. The reason why we say 18 inches is because we want to make sure that we're between any type of check valve.
Right.
Typically at 18 inches, I can look at the installation, tell whether there is a check valve there, and know that I'm not cutting the thermal expansion tank off with that check valve. Properly installed is the key. They have to be charged with air before you install the tank.
Yes, that's a big one.
You're going to match the air pressure inside the tank to equal pressure of the water pressure. Take a lazy hand gauge, any type of water pressure gauge, put it on the hose bib outside, see what the water pressure is, and then charge the tank to the exact same pressure before you install it. It needs to be a dry tank when you install. They do not have to be replaced necessarily every time you replace
the next
a water
question was,
heater.
do you have to replace it whenever, you know, whenever you replace a water heater?
Yeah,
So.
not necessarily. Possibly. It depends on, it needs to be checked. We need to see if the bladder is still good in the thermal expansion tank. We also need to make sure that it's charged properly at that time. If you're doing an install and then the bladder is good, and the best way to check that is just check the Schrader valve right there on the top. It's super easy. You need one tool, that tool. Hit that Schrader valve. If water comes out, the bladder's gone.
Yeah.
If air comes out, you're fine. Don't worry about it. Just charge it properly and move on.
All right. Do we have any more questions? Okay. I think we've got a couple more questions. Okay. Okay. The question is, if the pilot's lit but the main burner won't fire, and they're asking, I guess, on a specific model, but I guess the question is, can that happen? I guess.
Yeah, I think, and I believe I heard in my ear a GCV 4200, which is the older mechanical style gas valve. If the pilot is lit but the main burner will not light, the first thing I'm going to determine is, do I have a call for heat?
Right.
Like we talked about earlier, do we have hot water? Fill that TMP valve, see if there's hot water in the tank. There could be something that's preventing it from getting out into the plumbing system. It could be a plumbing leak, it could be other things. But if we have cold water in the tank and the temperature reading is set to 120 and the pilot's lit, then it's probably the valve at that point.
Yeah, but I would want to know if they actually are getting a call for heat. I mean, if it may be satisfied. Okay, and you know, you could. There's a lot of things that could happen with a situation like that, but you know, I would make sure that you do have a call for heat. And then, you know, if you had anything debris in by the burner, you might experience some
debris could cause that if you had a blockage in the burner orifice itself. Typically, what you normally see with that is you get a delayed ignition because it never, you know, maybe it's not blocked entirely, so you get some gas that's escaping around the chamber, and you kind of get a pop when it first lights. That's a delayed ignition. Now, it is possible if you pick up a lot of trash, it can clog that orifice. That's the importance of having drip legs or dirt legs on your gas line, because that's going to remove any of that scale. Black malleable pipe on the inside of that gas line will produce some scale. The dirt leg is there to catch any type of debris, scale, or anything like that. That way it doesn't get blown through the heater and possibly caught up in the orifice.
All right, next question. Okay, and the question is, how do we drain out sediment?
Depends on the heater. If we're doing this regularly, it's as simple as hooking a hose up to the bottom boiler drain, opening that boiler drain for 4 or 5 minutes and letting it
flush it out.
Yeah, letting it flush out. You don't have to drain the heater. You don't have to turn the water off. You don't have to do anything.
You just get the stuff off the bottom.
Yeah, just run a hose out into the yard, open that boiler drain, and let it run for 4 or 5 minutes. Now, if it's been a long time and it's never been drained, you may have to get more aggressive. You may have to what we call power flushing, which is basically you're taking the cold water supply and turning it off and on, off and on, off and on, trying to really hammer that water through there to break some of it up. Sometimes you have to back flush the heater, which basically means you're going to take a hose and force water through the boiler drain to kind of break some of that up. If it's been a really long time, you may not be able to get it out at all.
Yeah.
If it's
like an adobe brick in the bottom of the tank.
That's exactly what it does, and it literally bakes into
Yeah.
a brick because it's on the bottom of the top of the burner head at the bottom of the tank. So say the heater's 15 years old, it's never been drained, you probably won't get anything out. It is calcified to that point where it won't. There are some products on the market like Magarad, Unlime,
Yeah.
that are basically food grade delimers, basically vinegar. Vinegar will break down the calcium. You can put some things like that in it. Be careful with that, depending on the age of the unit. If this thing's 15, 16, 17 years old, sediment may be advantageous at that point because that sediment could be sealing up a small pinhole leak.
Yeah,
I've seen this a lot. You flush it out, you reuse the product, you remove everything, and 2 days later that heater's leaking.
Yeah,
So,
and at that age, I mean, it might be time for you to go ahead and start looking for one anyway.
yeah, absolutely, absolutely.
All right, any other questions? Okay, I think the question is, where would we place an expansion tank in an apartment? I guess you're talking about where you have not a lot of room, I guess.
It can be difficult, especially if we're inside a closet and there's just absolutely
Right.
no headroom there whatsoever. The tank doesn't have to be mounted in any specific position. Most of the time when you see a diagram, you're going to see it facing up. I don't know, Heather, can we get a shot of ours up here? You can kind of see how ours are installed. This is not necessary.
Okay.
This is not necessarily how every one of them need to be installed. You can put these in different directions. So if I have to force one down, if I have to point it straight out, we see ours there. There's a straight up configuration. You're usually going to see this in your diagrams piped in that way. That's ideal. But if you have to turn that down because of low headroom, or we have to point it straight out because of low headroom, that's fine. It's no big deal.
Now on an expansion tank, can you put it on the, does it matter? Does it have to be on the cold water side? If you don't have room, can you put it on the hot water side?
You can. Technically, it's going to do the same thing whether it's on the hot or the cold. We don't recommend the hot because over time, hot water can degrade
Right.
the butylene bladder. It's still going to take a long time, but it will reduce the lifespan with using hot water on the bladder as opposed to cold water on the bladder. That's the only reason why we say that.
Okay, the question is, I guess what they're asking is, how do you test an old thermocouple?
Okay.
You mean to get the...
Yeah, grab us a meter and we'll... Heather, if we can get an overhead. Basically what we're going to do, this is the tip of the thermocouple right here. This will be inside the pilot flame. So if we're going to do what we refer to as an open circuit test, which means we're just going to test the thermocouple itself. We're going to take this section out of the gas control valve. Leave this section in your pilot flame that goes out on your pilot assembly. All we're going to do is take one lead and we're going to touch it to the steel tip of the thermocouple. We're going to take the other lead and touch it anywhere on the copper body. As long as this is setting in the pilot flame, we should be producing a voltage.
Yeah, anywhere between 10 to 30 millivolts on this
Anything
one.
above 10, you're good to go.
Okay.
30 is about usually the max you're going to see out of a standard pilot flame. It's about all the heat you're going to get.
So
but
if you
you're
look at the
above 10,
tip
you're
here,
good to go.
I mean, yeah, that's where you're going to put it on the head here.
Yeah, there's two different metals here. We got a steel head that goes up inside the gas valve. One lead is going to go there. The other lead is just going to go on the copper body. So that will basically close our circuit
There we
when you
go.
see our voltage. And if you got above 10, you're good to go. If you got below 10, go ahead and replace it.
Yep. Any other questions? Say that one more time. Okay, I think the question is the exhaust size, is the exhaust size the same for a 50, I guess they're talking about just a standard direct vent.
Yeah, the direct vent heaters have a completely
Yeah.
different exhaust system than your normally atmospheric. You're going to see a 6-inch flexible, but what you're seeing there is basically two pipes. It is a pipe within a pipe.
It's a concentric
So,
vent.
Yeah, concentric vent. That's exactly what it is. So you're going to see a 3 or 4-inch pipe on the inside with a 5 or 6-inch pipe on the outside.
Your
but that's
exhaust
a
is coming out
completely-
the inner pipe, and your intake is we're pulling it in
Correct.
on the outside of that.
So that's a totally different venting system, and those heaters come with their own vent with it. You're going to get the flexible vent when you buy the heater. It will not use the standard B vent like a
No.
standard atmospheric would.
Okay, the question is, how long will a flexible gas line last?
No idea.
Yeah.
Yeah, it's not one of our products. I would say quite some time, depending on how much movement
Yeah,
is happening
I
with it.
guess
If it's being
use,
bent a lot,
yeah.
probably not long. But to be honest with you, since it's not one of our products, I can't
Yeah.
really speak to longevity.
All right, well, that looks like we're about done. That covers our topic, and I really appreciate all the questions. If you have any questions about anything we've covered here today, just email us at university@hotwater.com. If you have folks who missed this broadcast, a recorded version will be posted in about 24 hours on our new website, university.hotwater.com. You're on that website now, and go ahead and take a look around. We've got a number of videos that we've done, previous videos. And on that website, you can find those videos, and you can even register for classes. It kind of covers all the different types of training that we have available. It's a great website. I really encourage you to go look at it.
Yeah, we have a residential certification course
yes.
that's on there that will cover a lot of the stuff that we were talking about today, plus some additional stuff, especially on the older mechanical style gas valves. So browse around. Find that residential certification course, and again,
Yeah, it's a
we encourage
7-module
you to
course.
take it. It's a great course.
Yep, it's a 7-module course, and it covers everything that we think that they need to know
That's
about.
it.
All right. Well, really appreciate you tuning in. For Jason Leonard, I'm Jerry Winslet, and we'll see you next time.
Thanks, guys.